Okay, in terms of talking about continuity, these problems are, without a doubt, super popular. We have a test coming up next week. Expect to see stuff like this for sure. Let's maybe take a look at number 7 to get us started. But I guess what I'd really like to take into consideration, we should read the directions for 6, 7, and 8. Find A, B, or perhaps K, whatever variable that they're giving us, so that f is continuous at every point. And we already saw that continuity had the 3 criteria that we had listed up above. To be continuous at x equals c, there are 3 things. F of c is defined. We have to have our limit existing. The limit as x approaches c of f of x exists. And then finally, our third criteria is to actually say that that limit and the function value are in agreement. Now, I want to tell you the truth. When it comes to these types of problems, more often than not, the limit aspect, number 2, tends to be the most critical and the most important. And this is very true in this regard. Look, for number 7, as we're looking here, I want to state the obvious. The big question at hand is find k, and k, of course, is right over here. Find that value of k so that when we are working this problem out, our function will be continuous. Obviously, we're going to face this issue of continuity at x equals -4. So, look, I know normally we're talking about jumping to statement 1 that f of 4 would be defined. Actually, you can see by the lower assignment here, when x is equal to -4, we'll have kx plus 10. We will have our function defined. Really, the limit aspect is the key. For a limit to exist, would you agree our left side limit and our right side limit must be in agreement? So look, let's deal with the limit as x approaches 4 from the left. Now look, I've got assignment A and assignment B. If I'm approaching x from the left, which assignment would f be working with? If we're approaching 4 from the left, we're smaller. We're going to have A. Usually kids look at that and they'll say, what's so hard about that? Well, there isn't anything really tough about it. I hope you won't find. 4 times 4 is 16. 16 plus 7. Let's say, isn't that just 23? Yeah. Now look. Oh, is it -4? My apologies. Let's fix that up. Thank you. -16 plus 7. Thank you so much. We should get -9, right? Thank you. But look, and I miscopied that. We should also say the limit as x approaches -4 from the right. Now here it gets to be a little bit more interesting, doesn't it? This is where we face that ugly k value. And you'd say, wow, how do I work that limit out? I don't know what k is. K is just some number, right? K is just some number. So I'm going to say k times -4 plus 10. Kids real quickly will say, well, isn't that -4k plus 10? Yes. Okay, so this is our limit as we approach -4 from the right side. Now, if my limit is to exist, and that is required, that's the second requirement. If my limit exists, I have to have agreement from the left limit and the right limit, right? From the left-sided and the right-sided. What is that really saying? You're saying, well, that means -9 would have to equal -4k plus 10, right? So let's go ahead and see if we could solve that. Minus a 10 from both sides. You get negative 19 equals negative 4k. Divide by negative 4, what do we get? K is 19 over 4. Now, what that's really telling you guys is when k is equal to 19 over 4, the left side limit will be negative 9. We've guaranteed that the right side limit will have to be negative 9 also. And if you're really checking, you can say, well, don't you have to have 3 conditions? Wouldn't your function also have to be defined? And it should also, for a third condition, be equal to your limit. Well, yeah, you can see by this lower assignment for assignment B, when x equals negative 4, we will be arriving at kx plus 10. You will arrive at the same y value of negative 9. You can double check that. So, what's the answer here? Well, it would be answer choice A. By making sure that your limit exists, you're more or less agreeing that your function is going to be defined. And you're also guaranteeing that you're going to have agreement then. Okay, is this making sense, I hope? Look, sometimes it gets a little bit messier. Sometimes it gets a lot messier. And let's take a look at number 6. What makes this messier is that you've got an A and you've got a B. And you're going to have to find 2 things to get continuity. You see, what's happening is you have a 3-fold assignment for your function. And there are breaks. You can see that the problem seems to occur when x is breaking around negative 1. That's when you're going to have different equations assigned for f. And also when x is equal to 3. Now listen, as you're really trying to work this out, you can notice that there is a bar by negative 1 in the middle. This means x could equal negative 1. You're also going to see that x would equal 3 in the middle assignment as well. So, look, our function will be defined. Our function will be defined everywhere. The question is, will we have limit agreement? So now look, to have limits existing, what you have to have is left side and right side agreement. So I'm going to look at x approaching negative 1 from the left. And if I get that, look, I'm going to call this capital A, capital B, capital C. Which one are we looking at? Capital A. Why? Because I'm smaller than negative 1. If I'm smaller, I'm to the left of it. Kids will look at that and they'll say, that's no big deal. That's negative 1 squared. You should get a 1. Yes. But for a limit to exist at negative 1, you're also going to have agreement from the right. And as you're going just to the right of negative 1, which assignment, A, B, or C, are we really looking at? B. Now, this is where it can get to be a little upsetting, because when I plug negative 1 in for x, I'll have A times negative 1, and I'll have negative A plus B. And all of a sudden, kids look at that and they'll say, now wait just a moment. Wait just a moment. I've got 2 unknowns. I've got negative A plus B. And tell you what, I'm even going to erase all this stuff just so we can have some more space up above. What we're going to say is to have agreement means that negative A plus B should equal 1. Negative A plus B should equal 1. Wow, we're not done here. We're not done here at all. There's another issue that's causing trouble, and that's the break at 3. Obviously, we're defined at 3. We have x equaling 3 in the middle. So regardless of what we choose for A and B, our function will be defined when x equals 3. But the bigger question is, how do we get that limit to exist when x is equal to 3? Well, same thing. We have to have limits from the left and limits from the right. So I'm going to say the limit is x approaches 3 from the left. That means I'm what? Bigger or smaller than 3? Smaller than 3. If I'm going to be smaller than 3, am I working with assignment A, B, or C? Which one? B. So that means I'd have AX plus B. Plug in a 3. A times 3, you'd get 3A plus B. Here we go again. You get this puzzling, funny-looking limit. It's a value that exists. It's fine. You get 3A plus B. But wait a minute. We're also going to have to say the limit is x approaches 3 from the right. Now, guys, when you're going to have x approaching 3 from the right, you're bigger than 3. I hope we all agree you're really working with that bottom assignment of x plus 6. And if I'm going to plug in 3 from the right, just plug in a 3. 3 plus 6, hey, you get 9. What's that really saying? To be able to have this limit exist at x equals 3, as x is approaching 3, the left side limit and the right side limit have to be in agreement. What are we seeing? We are seeing, guys, that we have a second equation, namely 3a plus b is equal to 9. Now, right now, I hope you have visions in your mind of going back to Algebra 1, right? Back in Algebra 1, you learned the elimination method and the substitution method. And that's a wonderful way to solve systems of equations. That's what's really going on. If I add my equations right now at this very moment, will I be able to get one of those variables to cancel out? Not in the current form. 3a plus negative a wouldn't cancel out. B plus b wouldn't cancel. But how about I take this second equation and I multiply it by negative 1. Then you'd get a negative b, and then you get a negative 1. Sometimes kids will say, why on earth did you do that? Now I have a b and a negative b. If I add those two together, they cancel out. This is just going back to elimination. 3a plus an a will get you 4a. These go away. So what's a going to equal? 2? Hey, that's good news. Now look, you can take either one of these equations, maybe the negative a plus b equals 1, and you'd say, well, wait a minute. If a was equal to 2, I have negative 2 plus b is equal to 1. Now I can solve for b. Add a 2 to both sides. You have b equals 3. Guys, when you have a is equal to 2 and b is equal to 3, that will be the way that your two limits will exist. Your limit will exist as you approach negative 1. Your limit will exist as you approach 3. If you really think about it, because those limits are existing, you're not going to have any strange breaks where your assignment at 3 or at negative 1 can shoot off to a different value. You're going to meet all 3 criteria. So you can see that it's going to be answer choice B right over here. That would be true. Okay, so those are the types of problems that you can be faced with. Sometimes you have to deal with setting up a system of equations. Okay?